So if the density increases, the core shrinks, releases luminosity, and heats up. As the temperature increases, the region of the star that can undergo nuclear reactions increases slightly during the main sequence phase of evolution. So it's the increase in the temperature that compensates the decrease in hydrogen mass fraction, and the star produces more energy. So stars should become more luminous as they age in the main sequence. You'd see the star moving from point 1, which is in the main sequence, to the point 2. You see this track of the star increasing in luminosity. Now here at this point 2, the hydrogen is gone in the core. It leaves a core of pure helium ash. Now this helium core is not producing luminosity. It must be supported against gravity by thermal pressure alone. So the star loses sustentation against gravity and contracts. By contracting, it increases its temperature and moves from the point 2 to the point 3. Now at point 3, the temperature in the inner layers have increased to the point the hydrogen burning occurs in a shell around the inert helium ash. So this is what happens here as the hydrogen is gone in the core. The star stops producing energy, it contracts, and the core heats up. As the core is heating up, the structure of the star is going to become like this. You have the non-burning helium ash, the temperature becomes high enough in a hydrogen layer around the core, and this is the phase of hydrogen shell burning. From the outside, the star has reached the subgiant branch. These are evolutionary curves for stars of different masses. We're following the evolution of star mass 1 solar mass. So around this point here, the point 3, the star is burning hydrogen in a shell around the inert helium ash. So the star is now burning hydrogen again, using fuel that in the main sequence phase was simply around the core and not available for burning. As the volume of the star that generates this energy is larger, and also because the temperature of the burning is hotter, more energy is being released than in the main sequence stage. The star gets more luminous, the envelope expands, and the temperature in the atmosphere decreases. In this phase of shell burning, the star is at the subgiant branch. So this is the subgiant branch. The establishment of a shell source of hydrogen burning occurs around here. And then hydrogen starts burning in a thick shell here. This phase for stars like the sun lasts for about 1 or 2 million years.